So good afternoon, ladies and gentlemen. My name is Adamovsky, and I'm here with a topic which our team focused on for 2 years. And the topic is residential ventilation unit with thermoelectric heat exchanger for control of supply air temperature. So what is this complicated title about? Basically, if you imagine today's situation with residential buildings, you may recognize typical problem. And this problem is a lack of ventilation, poor air quality, etc. And basically, the fundamental solution, which is on the other side pretty simple, is proper ventilation. But there are a lot of other influences which are important to incorporate in thinking about proper ventilation. On the first side, it is air quality of air what we have in buildings. But also, there are, and many colleagues already have spoken about that, strong requirements for energy efficiency and energy savings in buildings. Sometimes those two requirements go against each other, and I think our solution combines them and improves typical ventilation unit for flats, maybe family houses. So what novel we have? Basically, if you look at such a scheme, our ventilation unit we are now working on, and we have developed a kind of prototype, consists of typical components. You may find these components in other ventilation units as well. What is new is what we call active heat exchanger. This heat exchanger brings new functionality for typical ventilation units. And this active heat exchanger provide temperature control of supply air, which usual ventilation units don't have. You could heat up supply air, and if you have complicated system with cooling system inside, you could maybe even cool supply air. Our unit is doing all of this in one piece. So this active heat exchanger, which I will present a bit more later, is in ventilation unit together with typical components such as heat recovery heat exchanger, such as air filters, which we need for refreshing outside air, as well as extracted air which goes back into the ventilation unit. There is in most cases also necessary preheating module, and at this point we are thinking also about application of thermoelectric modules in preheating as well. It is just an idea. When fans, which are obviously necessary for airflow and transport of air through ventilation system. And what is not typical, in comparison with regular units, we add two proportionally mixing dampers which may enhance airflow rate, which goes to active heat exchanger. And I will speak later why we do that. And bypass dampers. That's the last component which is important to mention, and it's typical for bypass function of heat recovery and heat exchanger. So let's share a little bit about active heat exchanger. So what is this all about? I have mentioned, and it is in the title of our topic, that we use thermoelectric modules to provide additional control of supply air temperature. And this heat exchanger is quite a pretty simple construction. Basically, we have two aluminum heat exchangers which stick together with thermoelectric modules. And these modules are fed with electric current, and following their functionality, one side of this module heats up while the other one cools down. And therefore, we could control supply air temperature. And there is obviously a lot of details which I'm not going to spend right now around construction of this heat exchanger. But basically, we have tried a lot of options, a lot of variants, and the most promising right now consists of 12 pieces of thermoelectric modules of 50 times 50 millimeters size, which is basically the most common which you could find on the market. So not only schemes, I would like to share a few pictures as well. So on the picture on your left side, you could see our prototype or functional sample of ventilation unit. And this is dedicated for flat ventilation, for typical apartment which you could find in typical development today. So it is quite slim dimensions, so you could fit it in small rooms such as toilet room, and it allows vertical, horizontal position, etc. What you could see on the right side is aluminum heat exchanger with thermoelectric modules, and on the bottom picture is another very important component I have forgotten to mention, and it is control system. And at this point I must thank to our colleagues who developed this control system, which is critical for efficient function of this ventilation unit. So few results and few performance parameters I would like to share with you as well. Basically, we have done testing, and a lot of testing even on previous versions. This version we call Mark 4, maybe Mark 5. Sorry, I have forgotten which evolution is it. And basically, I would like to share with you two setups we have measured. Both represents cooling regime. Basically, this unit has excellent performance for heating up air. For winter regime, and it may serve quite efficiently for warm air heating. But cooling is bigger challenge. So I would like to present rather the situation for cooling. On this picture, you could see our ventilation unit mounted in the testing lab. It was connected to supporting ventilation units, which provided airflow rates with required inlet temperature, airflow rate, and other parameters we required for the experiment. And at this point, I would like to present two airflow rate states, 76 cubic meters per hour and 147 cubic meters per hour at two temperatures, 23.5, which represents maybe spring or maybe mild summer, and hot summer when inlet air temperature is at 30 degrees centigrade. So what you could see on this picture, there are a lot of curves, I know. Basically, full curves represents states with lower inlet temperature, 23.5. Dashed curves represents states with higher summer, really summer conditions. And what you could see here are cooling outputs. And you may recognize that on this diagram, where on the vertical x is cooling output, on horizontal x is electric input, and on the other vertical x is energy efficiency ratio. What you could see, first with cooling output, it is increasing with electric input, but the increase is not straight. It is with higher input, it is slowing its increase. And the reason is that in that heat exchanger, there is a lot of heat which goes against our cooling output. It's called joule heat, and it's also heat which is conducted from hotter to colder components of this heat exchanger. So there is limit, and this limit would show a peak cooling output, and then with even increasing electric input, the cooling output will decrease. It's typical for thermoelectric modules. What you could see also is mentioned energy efficiency ratio. Those are other curves which starts on the top on the left side and goes smaller and smaller on the other side of the diagram. And obviously there is a limit which makes sense to run such a ventilation unit, and we expect energy efficiency ratio, the minimum one, 1.0, the minimum sufficient energy efficiency ratio. And basically that represents for smaller airflow rate, cooling capacity or cooling output around 120 watts, while with increased 147 cubic meters per hour, we get to over 300 watts for entire ventilation unit. So following our experiments, we may say that we could create a ventilation unit which works well and improve indoor environment, not only with a functionality of supplying fresh air, which is the fundamental function, but also controlling the supply air temperature whole year. During winter, we could do heating of supply air, but during summer, we could cool down the supply air. But it has some problems. Basically, for our further development, we need to improve air tightness of entire construction. It's one step, and I think we could solve that quite easily, and it's already being done. The other thing is that we need to improve even more performance of the active heat exchanger, and there is a lot of issues we need to solve, starting from flow organization, going through better heat transfer from solid aluminum heat exchangers to air, because air transfer of heat to air is quite weak. And another very important task is to finish control system, because that control system must follow results of what you see in the previous diagram. And the reason is that if we want to provide even energy sufficient function, we could not reach states when the operation is not efficient. So in that control algorithm, this must be respected as well. And there is another issue which is maybe even more further for our development, and it is replacement of aluminum heat exchangers, because basically I think practical biggest disadvantage of this unit is a high weight. It is over 30 kilos at this point. So we would like to replace this heavyweight and also costly aluminum heat exchangers by another construction. So let me conclude our presentation. So we have great theme in residential buildings, and it is ventilation. We need to provide energy efficient solution, but quality of environment we provide for occupants is more important. And I think our solution of ventilation unit, which has quite rich application and rich functionality, serves to fulfill both requirements. Thank you for your attention.